of combustion. Enthalpy of combustion. What is this enthalpy of combustion? Okay, if you have understood the enthalpy of formation, then you can easily remember the definition of enthalpy of combustion. This is defined as the enthalpy change when 1 mole of a substance is completely burned in excess of oxygen or air. Okay, so enthalpy of combustion is defined as the enthalpy change when 1 mole of a substance is completely burned in excess of oxygen or air. It is denoted by delta CH. Let us discuss some examples of enthalpy of combustion. Number 1 is combustion of carbon. You know, C solid plus O2 gas, this gives CO2 gas. Now in this case you can see that 1 mole of carbon is burnt completely to give carbon dioxide. So here the enthalpy delta H is delta CH. This is called enthalpy of combustion, and this is equal to minus 393.5 kilojoule. Then second example is combustion of methane. Combustion of methane, the reaction is CH4 gas plus 2O2 gas. This gives CO2 gas plus 2H2O liquid. Now here delta CH is equal to minus 890.3 kilojoule. What does it mean? It means that when 1 mole of methane is completely burnt, okay, then 890.3 kilojoule of energy or heat is released. Okay. Similarly, we can have another example, combustion of ethyl alcohol. Combustion of ethyl alcohol, C2H5OH liquid plus 15 by 2 O2 gas. This gives, C2H5OH liquid plus 3O2 gas. This gives 2 CO2 gas plus 3H2O liquid. Now delta CH in this case is minus 1367.4 kilojoule. What does it mean? It means when 1 mole of ethyl alcohol is burnt completely, then 1367, that is 1367.4 kilojoule of heat is released. Similarly, cooking gas in cylinders, cooking cylinder, LPG cylinder contains mostly butane, C4H10. During complete combustion of 1 mole of butane, 2658 kilojoule of heat is released. So, how can you write this? It can be written like, C4H10 gas plus 13 by 2 O2, 13 upon 2 O2 gas. This gives 4 CO2 gas plus 5 H2O liquid. Now delta CH naught is equal to minus 2658.0 kilojoule per mole. Okay. Similarly, when combustion of sucrose, sucrose is what? Sugar, table sugar. Okay. So combustion of sucrose releases 2802 kilojoule per mole of heat. Now sucrose is chini, C12H22O11, table sugar. Plus this requires 6 O2 gas. This will give 6 CO2 gas plus 6 H2O liquid. Now here delta CH naught is equal to minus 2802 kilojoule per mole. Now you can see one thing, that the enthalpy of combustion is always negative. Why? Because combustion reactions are always exothermic and heat is evolved during combustion. Whenever we burn anything, heat is always released, isn't it? So enthalpy of combustion of all the substances are always negative. Now let us discuss calorific value of foods and fuels. This is another topic, calorific value of foods and fuels. You know, the energy released by the combustion of foods or fuels is usually compared in terms of their calorific value. Okay, now what is this calorific value? Calorific value is defined as the amount of heat produced in calories or joules when 1 gram of a substance is completely burnt. Okay, I repeat, calorific value is defined as the amount of heat produced in calories when 1 gram of a substance is completely burnt. Calorific value is usually expressed in kilocalorie per gram or kilojoule per gram. Now let us consider examples. You know, when methane burns, you know, CH4 gas plus 2O2 gas gives CO2 gas plus 2H2O liquid. Now delta CH naught in this case is minus 890.3 kilojoule. Now it means what? It means when 16 gram of methane is burnt completely, then 890.3 kilojoule of energy is released. So what is the calorific value? Calorific value is for per gram. So the calorific value for methane is equal to 890.3 divided by 16, and that is equal to 55.6 kilojoule. So 55.6 kilojoule of energy is released per gram of methane. Is it clear? Similarly, when petrol or octane, which is a component of gasoline, burns, then its reaction is C8H18 liquid plus 25 upon 2O2 gas. This gives 8 CO2 plus 9 H2O liquid. In this case, delta CH naught is equal to minus 5460 kilojoule. So the calorific value of this octane is 5460 divided by 114. 114 is the molecular mass. So this is equal to 47.9 kilojoule per mole. Okay. So the calorific value of octane is 47.9 kilojoule per gram. Calorific value of methane is 55.6 kilojoule per gram. So basically, calorific value is used to compare the efficiency of the fuels. Well, now, calorific values of some important foodstuffs and fuels are given in this table. You can just look at the table. This table is going to help you throughout your life, because if you remember the values, then it will be useful. You know, the charcoal has a calorific value of 33 kilojoule per gram. Okay. Similarly, the values of hydrogen, methane, butane, butter, ghee, milk, curd, honey, rice, egg, meat, everything is given. Now, among the foods, fats and carbohydrates are the principal sources of energy, because these have high calorific values. Okay. Proteins are also the main constituents of our foods. On an average, an adult requires nearly 8,000 to 12,000 kilojoule of energy per day. It means that the balanced diet of a person must include foodstuffs which provide enough carbohydrates, fats, proteins, oils, vitamins, etc. Now, from the calorific values of different foods, it is possible it is possible to calculate the food requirement of average person for a balanced diet. Or from the calorific value, if we have the idea about the calorific value, we can plan our diet depending upon the requirement.